Question 8, another quadratic question. Sn represents the distance of an accelerating particle from a point P, and we're given the first four terms here, first and second differences. So here's our terms. So we've 13, 17, and we have 21. So 2a is the second difference, which is 4. A is 2. Term 0. 21, 17, 13, this will be 9. And 9 minus 9 will be 0. So C is equal to 0. And A plus B plus C is term 1, which is 9. So A is 2, so therefore B is equal to 7. So we have 2n squared plus 7n. Looks to be Tn here. Let's check T4 here. That would be 2 by 16, 32, plus 7 fours, 28 is 60. So you've checked one, it's correct, so you have to have done it correctly. So it's quadratic clearly. Second difference same, S5, so T5 is 2 by 25, 50, plus 7 by 5, 35, that's 85 for T5. And assuming we have found A, B, and C, S100. So we're calling it T here. T100 is equal to 2 by 100 squared plus 7 by 100. So that's 2 by 10,000, so 20,000 and 700. So 20,000 plus 700 looks like T100. And then find S100 minus S99, so that's the distance traveled in the 100th second, or the 99th second. So S99 or T99 is 2 by 99 squared plus 7 by 99. Get my calculator out for this one. Gives 20,295, and T100 was 2,700, so 20,700 minus 20,295 would be the distance traveled between second 99 and 100. So that's 405 meters, and that's the meaning of what S100 minus S99 is. Question 9, we have this sequence. H0 is equal to 1. H1 is 16.2. H2 29.8. So just decimals, the same type of question. The sequence starts, we're given term 0 here. So we have 16.2 to 29.8. So we look at the differences. When we say the height is traveled from 1 meter, obviously it's H0 is 1, so 1 meter above the ground. After 1 second, it's 16.2, then 29.8. So it goes up 13.6 between these two. It goes up slightly less, exactly 12 actually. And then between these two, slightly less again. That is going to be 10.4. 10.4. That's the first difference. Second difference is minus. Be careful here when they're minus. Minus 1.6. Is that consistent? It is. So we have 2a is minus 1.6. So a is equal to minus 0.8. We already have c is equal to 1. A plus B plus C is equal to term 1, if you want to write it out in long form. So A plus C is 0.2, plus B is 16.2, so B has to be 16. So Tn is going to be equal to minus 0.8 n squared plus 16n plus 1. So these are the questions. So we've already shown it's quadratic, and we found A, B, and C. Calculus, so it remains to find the max height of the golf ball. Well, we have Hn is called Hn, actually not Tn, let's call it Hn. So we differentiate this with respect to n. So we're differentiating Hn with respect to n. So dHn or dn you can call it y if you wanted, and do dy dx is minus 1.6n plus 16. This would have to be equal to 0 at the max value. The slope is going to go up. It's an inverted quadratic. So at this point, slope is 0. So 1.6n is equal to 16. So after 10 seconds, it's reached its max height. Find the max height. Actually, we have to find the max height. So h of 10 is equal to minus 0.8 by 10 squared, which is 100 plus 16 by 10 is 160. I'll add the 1 onto this one, 161. So that's 161 minus 80 is equal to 81 meters, the max height. And by comparing the expression for Hm with a formula for displacement under constant acceleration, or by some other method such as calculus, evaluate the acceleration due to gravity at the surface of the moon. Okay. This goes right back to the beginning of the question about the astronaut on the moon. Acceleration is d2y dx2, or in this case, if we d2hn, so h d2n is equal to, it's just going to be minus 1.6, acceleration ms to the minus 2 for the last part of this question.